How does an irradiance sensor work? The sensor measures irradiance by converting sunlight into an electrical signal. When solar radiation reaches the PV cell, the cell generates a photocurrent that is proportional to the irradiance level. This photocurrent passes through a precision shunt resistor, converting it into a proportional voltage signal. The electronics board, PCB, then takes two inputs: the voltage signal from the shunt resistor and the temperature signal from the PT1000 mounted on the back of the PV cell. Using these together, the PCB applies temperature compensation, filters and calibrates the measurement, and generates the final temperature-compensated irradiance output in watts per square meter. 7 Irradiance sensor is available with two output options: RS485, Modbus, RTU, Sunspec compliant, with an irradiance range of 0 to 1,600 watts per square meter, and an analog 4 to 20 milliamps output with a range of 0 to 1,500 watts per square meter. Where is the irradiance sensor used? Irradiance sensors are mainly used in photovoltaic power plants. They provide reference irradiance data for performance ratio and yield monitoring, and help identify efficiency losses and system faults. They are also used during solar resource assessment to evaluate site potential and support reliable energy production forecasts. In addition, irradiance sensors are integrated into weather stations and research applications for solar radiation monitoring, PV testing, and performance validation. Irradiance sensors can also be used in agriculture, where they help monitor sunlight exposure for crops and support greenhouse control systems to maintain optimal growing conditions. With accurate temperature-compensated measurements, irradiance sensors support smarter monitoring and better performance across solar and environmental applications.